A routine push. Add, commit, push. Then a few minutes of nothing. Then things start breaking. Then the email. GitHub. Then another one. AWS. Key revocation notices. That's a real write-up by the developer it happened to. And the story usually stops there. Key leaked, key revoked, lesson learned, move on. But revoking the key only closes the thing that got out. It doesn't touch the question underneath it. While that key was live, who was allowed to read what? For most of us, the honest answer is that nobody ever decided. It wasn't a bad decision. There was no decision. The permissions or whatever fell out of the order, the features got built in. One developer described exactly that shape of problem. Generated code using row-level security that fails open, so it quietly stops filtering other people's data. Nothing errors, nothing alerts. The feature works for everyone, including the people it shouldn't work for. The lock was fine. The door was never hung. Now, rotating that secret is real work. How far it reached, what else it touched, whether your system can even swap a secret without a redeploy. That's the whole of part 2. This part is about the door. Here's the awkward thing about the security layer. Most of us have never seen it written down as a whole. We've seen pieces of it, and usually we saw them because somebody else owned them and we had to file a ticket. So before anything else, the inventory, not the top 10 list. That's a ranking of what goes wrong, which is a different document. I mean the contents. There are 7 groups. The architectural models. Deny by default, meaning nothing is allowed unless a rule allows it. Least privilege, and the shape of your permission model. Identity, session, and state. The authorization logic itself. The defensive and detective controls. Rate limiting, lockout, logging, alerting. The environmental ones. Repositories, pipelines, environments. And the lifecycle work? Threat modeling, review, testing, disclosure. 7 groups, and you have probably touched 2 of them. The contents come from the standards themselves. The grouping into 7 is a reading of them, and I'll own that rather than pretend it's handed down. One definition, once, because our own sources genuinely don't agree. The standards use access control and authorization as synonyms in some places. One of them says outright that it uses the terms interchangeably. So, for this episode, access control is the whole layer. Authorization is the specific part that decides what a caller may do. 2 things have to exist before you write a single check, and neither of them is code. The first is a boundary. Something that says, this is inside, that's outside, and here is what crosses between them. The standard's phrasing is that a trust boundary marks out blast radius, and it's the controls that enforce it. That matters because it tells you where checks even go. Without it, you write checks where you happen to remember, which is not where they're needed. Naming that boundary is where threat modeling starts. And that's the whole of what I'll say about it. It's the mechanism under everything that follows, and it deserves better than 4 minutes. Here's why skipping it doesn't get rescued later. Bad design can't be fixed by good implementation. In the standard's own words, an insecure design cannot be fixed by a perfect implementation because the needed control was never created. You can write flawless code enforcing a rule you never wrote down. The second thing is criteria. Some bar a change has to clear before you'll call it done. And here I'll be honest with you about the frameworks. They assume an organization. Inside the practice on roles and responsibilities, one task asks you to obtain upper management commitment. If you are the whole team, there is nobody to escalate to and nobody to sponsor anything, which is what most developers reach for anyway. Around 6 in 10 say they'd take a security or ethical concern to a person rather than decide it alone. That instinct is fine. It just doesn't have anywhere to land when the team is one. The usable version is the framework's own example, not mine. Add a security line to a checklist you already run. Your definition of done. That's it. That's the entire prerequisite. One line before the first scanner. Boundary drawn, which leaves the question every check depends on. Who is calling? Identity feels like a solved problem because you can buy it. The decisions inside it are still yours, and buying the box doesn't buy the decisions. There are 4, and they come in order. Proofing. How do you know the first time that this person is who they claim? Usually that's an email round trip, and that is a decision, not a default. You've decided that control of an inbox is sufficient proof. For a notes app, fine. For anything holding money or someone else's data, you've just set your floor. Then memory. Session or token. A session is something your server remembers. A token is something the caller carries. The difference people discover late is revocation. You can delete a session, but a token you already handed out is valid until it expires, unless you built something that says otherwise. Whichever you pick, you own that story. Then, who vouches? Your own login or a federated one. Sign in with somebody else. This is the one people think removes work. It moves it. Now you're deciding token lifetimes, which services a token is even valid for, and what happens when that provider's account gets taken over. Then step up. Not do we have multi-factor? When do we ask again? Changing a payout destination should not feel the same as changing a display name. If everything in your product costs the same to do, you haven't made this decision either. Now notice what comes out of the far end. Not a login. A principal. A named, typed thing the rest of your system can reason about. That's the output of this whole block. It answers exactly one question. Who is calling? And every time it gets asked to answer more than that, something downstream breaks. That block has a name. Authentication. And authentication and authorization get taught as two words that sound alike and get confused. There is a concrete place where one ends and the other begins, and it isn't a metaphor you hold in your head. It's a field. Which kind of token you're holding? The verification standards requirement is that a service check a token is the right type and meant for that purpose before trusting what's inside. Its own example is exactly this seam. Access tokens for authorization decisions, identity tokens for proving who someone is. Two typed things going to two different consumers. Using the identity token to authorize is a real, common, findable bug, not a philosophical error. And that seam gives us the order. For any protected resource, the decision needs an authenticated principal first. Authentication happens, and only then can an access decision be made. Two honest edges, because I'd rather you hear them from me. Public resources are the stated exception. The guidance is denied by default, except for public resources. A page anyone can read is still an access control decision. It's just one that resolves to yes. And the word principal is doing real work. The standards call the requester a subject. Most often a human, they say, but a non-person entity, like an autonomous service or application, fills the same role. Hold on to that. It's how the same machinery covers a service, a job, or an agent acting on somebody's behalf. So, the decision itself. What may this principle do? The most common failure in the entire layer, and the one your tooling is worst at finding. Start with the number, because it's worse than you'd guess. In OWASP's current top 10, broken access control sits at number 1, and across the applications tested, 100% had some form of it. Not most. All of them in that corpus. So picture what you'd need to check it. A grid. Rolls down one side, resources across the top. Every cell answers one question. May this caller do this thing? Now run a scanner across that grid. The scanner is genuinely good at empty cells. A missing check has a shape. There's no call, no guard, nothing between the request and the data. That's a pattern, and tools find patterns. Then it reaches a cell that's filled in. There's a check. It compiles. It runs. It returns a decision. And the scanner has no opinion, because whether that decision is correct isn't in your code. It's in your head. It's the sentence an editor should see drafts in their own workspace and nobody else's. And that sentence was never written anywhere a program can read. The code faithfully implements whatever you meant that day. WASP put this plainly in the 2017 edition of the list. Static and dynamic tools can detect the absence of access control, but cannot verify it's functional when it is present. That line isn't in the current list, so treat the wording as dated. And notice it's weaker than our actual problem. A tool can't tell you the check works. It certainly can't tell you the rule is the one you meant. The current authorization guidance hits the same wall from the other side. Unit and integration tests, it says, can never replace manual testing by a skilled hacker. And the tools that get closest actually prove the point rather than beating it. The good ones automate the comparison. They'll replay every request as every role and diff what comes back. That's real, and you should use it. But you have to hand it the matrix first. It tests your intent, it doesn't discover it. The research that finds these automatically finds candidate locations from your API structure, not correctness. Absence is detectable. Correctness is not. Which tells you what owning this looks like in practice. And it isn't a tool you buy. It's a review done by a person on a cadence, because only a person knows who is supposed to see the record. That's the whole reason access review shows up in this guidance as a recurring activity rather than a one-time task. All of which works while there's one grid to review. The thing that breaks first isn't traffic, it's nesting. One resource is easy. Then the resource lives in a project. The project lives in a workspace. The workspace belongs to an organization. And somewhere in there, a customer says, this contractor should see these two projects, but not the third, and not the billing. Every level you add multiplies the decisions. And because the checks were written service by service as the features shipped, the logic starts drifting apart. Copy by copy, each one slightly out of date with the others. That's not sloppiness. That's what happens to duplicated rules over time. That specific problem, many tenants multiplied by nested resources, is why centralized authorization systems got built in the first place. But take the counterweight seriously. It's in the same paper. Google's is called Zanzibar, and it holds trillions of relationships, but carved into more than 1,500 namespaces, roughly one per client application. The median namespace, one application slice, is around 15,000 relationships and about 500 lines of configuration. That is not planetary scale. That is a normal product with real customers. So the lesson isn't go build what Google built. It's that the threshold arrives much earlier than the scale stories suggest. And knowing where it is tells you when consolidating stops being over-engineering. Now, everything I've described so far assumes you're starting from nothing. Almost nobody watching this is. Nothing I've said stops being true. Boundaries, identity, the seam, the decision nobody's tooling can check. That's the layer either way. What changes is the order you're allowed to touch it in. And that's the gap. Because every guide to this layer is written for a system that doesn't exist yet. Design it in from the start. Threat model before you write code. Choose your permission model early, because it's expensive to change. All good advice. For a room you are not standing in. The standards are unusually candid about this, and it's worth hearing how directly they say it. The Secure Development Framework names the transition. How an organization moves from what it does today to what the framework asks for, as future work that may expand the publication later, which is to say, not in the document you are holding. The access control guidance concedes that re-engineering access control with a new pattern later is often difficult and time-consuming. And secure design, one of them says, is neither an add-on nor a tool that you can add to software. They're not wrong about any of that. They're just not talking to you. So what follows isn't a standard, and I'll flag that every time it comes up. You cannot switch authorization on. Get one step wrong, and you take the product down for people who were legitimately using it, which is how this gets postponed for another quarter. So, 5 steps in this order. 1. Inventory. Find every place a decision actually gets made, not every endpoint, every decision. They'll be in your root handlers, your middleware, your queries, and at least one will be sitting in a template deciding whether to render a button. 2. Derive the policy from the system's actual state, not from the spec. Whatever document exists describes a system nobody built. The permissions people really have are in your data. The memberships, the ownership columns, the flags somebody added for one customer in 2024. Read those. That's your starting policy, whether you like it or not. 3. Shadow mode. Stand a new authorization engine up beside the live path and give it a copy of every request. It decides, and it writes down what it decided. It does not enforce anything. A wrong policy costs you a log line instead of an outage, which is what makes the whole thing survivable. That step isn't mine, and it isn't a standard. It's in OpenFGA's own migration documentation, and the general pattern goes back to a library GitHub published in 2016 called Scientist, whose canonical worked example is, of all things, a permissions refactor. 4. Reconcile. Every disagreement between the two lanes is one of two things: a bug in your new policy, or a permission somebody has had for a year and shouldn't. Both are findings. This is standing work for a while, not an afternoon. 5. Flip. One resource type at a time, move the decision from the old lane to the new one. Deny by default lands last, once the disagreement log has gone quiet. And I owe you an objection, because the standards raise it themselves. They ask for a single access control routine consolidated in one place. This runs too. The answer is that the shadow lane never decides anything. It only observes. And the flip is a time-boxed convergence toward exactly the one routine they're asking for. If that dual window isn't time-boxed, then they're right, and I'm wrong, and you've built a second thing to maintain forever. So, the boundary before any code, identity, and the principle that comes out of it. The seam, a typed field, not a metaphor. The decision nobody's tooling can check for you, and what owning it actually costs. And an order you can retrofit in without taking the product down. That's the door. Keep the shape of it. The contents are fixed. The order is the part nobody hands you. And step 1 needs no new tools. Go find every place in your code that decides who may do what. It is not the layer. Environments, repository access, pipeline permissions, those are access control too. The same sources list them right alongside the rest of it, and they belong to part 2, along with the secret from the first minute of this episode, which we revoked and never actually dealt with. Next, the substrate, secrets, configuration, and the supply chain you didn't write. Thanks for watching. If this changed how you look at something you already shipped, pass it to whoever owns the part nobody chose. Subscribe to AI TechBook, Part 2, Secrets, Configuration, and the Supply Chain You Didn't Write.